2 software will propagate from here on out, and we'll use velocity and acceleration. So we have powered off our star tracker, and we're on our NOV 2 software, and everything's looking great.
Okay. Thanks, Julie.
Thanks.
All right, the cruise stage separation is just about 4 minutes away, and Rob Manning joins now. Rob is the chief engineer here at JPL and an absolute veteran of Mars landings. We're going to play a little video for you right now. You haven't seen it yet, but we'll roll it. Let's go ahead. This is
Lander, I still alive. 14 reports carrier lock at
that day, Rob. There you are. You were the phase lead. You were sitting up front.
Yeah. That's what I look like when it's successful.
Yes.
I hate to see what it would be like if I wasn't successful.
But talk about that. What is EDL like? Why is it so hard?
Well, it's many years of work by many, many people who struggle to put all the pieces together, and particularly because we can't really test entry, descent, and landing on this planet. It's much more complicated. Mars has a lower atmosphere, thinner atmosphere, less gravity. You just can't put the pieces. So imagine you had a big Broadway production, but you couldn't really do the show until all the audience shows up. So that's what it feels like. So you never really know if you've really done it right.
Well, we've done it 7 times. Can we say that, hey, piece of cake, we know what we're doing?
No, I don't think so. I mean, we get better at it. There's no doubt. We've learned for both the successes and our own failures, including failures of other missions outside of this country. So those pieces come together in our mind's eye. We try to put what we learn together and just do the best we can. And if we don't succeed, we will learn, because we are collecting data on the way down. If something bad happens today, we'll be able to take what we learned, even though we may fall on the ground after getting kicked off the horse. We'll get back up, brush ourselves off, figure out what we did wrong, and get back on the horse.
Well, there's a lot of uncertainty. Just very quickly, give us some possible scenarios of what could happen during EDL today, especially during communications.
Well, the great news about having communications, there's almost anything that go wrong, there's a very good chance we'll figure it out. But things like, the parachute has to go right. We know you don't open parachutes on Earth going Mach 1.5 times the speed of sound. You just don't do that. You don't need to on this planet. But we have to, because if we waited any longer, we'd be on the ground. The very complicated radar system has to work from outer space all the way to the ground and look for the ground. What if it locked up on the heat shield? Well, we've tried to avoid that problem. We fixed that problem, we think, to prevent that from happening. But what if we got it wrong? Things like that could happen, and our vehicle could have things bad happen. But we've worked hard to prevent them.
So
at this time, we expect
getting
that
close. We're going to go to the
recording has
control room
started.
for cruise stage separation, Rob.
Okay.
Thank you, MRO.
I need to take off common. Yeah, yes.
InSight Systems, EDL comma.
Go ahead.
On InSight Court. At this time, MRO will have loaded their electro sequences. Marco is expecting carrier lock at any time. Marco B is reported there in bent pipe. Still waiting on A.
Copy that. Thank you.
Radio Science report, UHF carrier detected.
EDLCom, Marco Alpha is in vent pipe mode. Marco Bravo has locked on the carrier. Marco Alpha has also locked on carrier.
System base on InSight cord. As expected, the DSN has LOS for InSight expand.
Copy that. Thank you. All station InSight systems on InSight cord. DSN has lost the X-band signal from InSight, indicated expected cruise stage separation. Standing by for UHF signal acquisition via Marco or Radio Science.
We are about 5 minutes from entry and have confirmation we've lost the X-band signal from InSight. This was expected because we have transitioned from the antenna on the cruise stage to the UHF antenna on board the spacecraft. Ground stations have detected the UHF signal and Marco has locked on the signal. This confirms that InSight is transmitting UHF signals as expected. InSight telemetry through the Marco relay is not expected until about 2 minutes before entry.
So, Rob, that was exactly what we were hoping to hear, that
Yes.
the Marcos are
The vehicle
working.
has also performed the turn to entry maneuver. The vehicle is turning away from a sun-pointing attitude and oriented itself to enter the Martian atmosphere.
This is a big first step. Getting the cruise stage separated. It's now, after the vehicle turns itself to the right orientation, the cruise stage is now going to be get further and further away until it's about 3 or 4 football fields away, and will burn up in parallel as the vehicle enters Mars.
And Christine mentioned turn to entry. What does that mean?
Well, it's because the cruise stage has to be pushed off to one side, like this. The rest of the vehicle has to turn to face the atmosphere and to be dead nuts on as it hits the top of the atmosphere.
So this is taking all the heat coming into the atmosphere.
Exactly. It'll be both provide a source of drag, but also thermal protection because it gets over 1,500 degrees Celsius on the top on this heat shield. Very, very hot. But on the inside of the heat shield, it's maybe only a fraction of a few degrees above room temperature. So it's a wonderful protective device to keep our lander safe.
All right. So the next thing we're standing by for is
entry. Getting to the top of the atmosphere, gradually slowing down. Right now, the vehicle's just now beginning to, very soon, we'll be beginning to feel the atmosphere touching it. Actually, entry is above the atmosphere slightly, so it's really not until half a minute or so after entry, before we start really detecting the fact that that atmosphere is slowing us down.
All right. We'll be standing by.
Yes, exciting.
Rob, now entry is scheduled for 11:47. the cruise state SEP and the entry times are locked in, correct?
They are. They're locked in when we selected the target and aimed the vehicle very precisely. That allows us to know exactly when we hit the entry point, which is 55 kilometers from the center of Mars.
So we know those times are locked in, but what about all the other events that take place in EDL?
Radio Science reports dropping carrier power as
EDL-com,
expected.
Marco A and Marco B have telemetry.
Just heard, both Marcos have telemetry.
They are doing their job. These small CubeSats are relaying ones and zeros with a few seconds lag from the vehicle up to these two vehicles, and they forward them back to Earth to the Deep Space Network using X-band antennas.
And keep in mind, this was all an experiment. We weren't sure that this was going to work, but we had this need that we didn't have live communication.
That's right.
In this particular mission.
Well, we don't really need communications. We don't need their information, except if something went wrong. We would very much like to get the data right now. We have other
We are now
spacecraft.
receiving InSight telemetry via the Marco relay.
It's flowing into their state. This is fabulous. That means the team now can watch the data flowing onto their screens as if they're communicating directly
This data
to the
will
vehicle.
provide detailed information about the state of the spacecraft throughout EDL.
We were on pins and needles waiting for that because we weren't really sure.
This is wonderful news. This will allow us to give some, if this continues working all the way to the ground and beyond, we might even see a first picture from the surface of Mars
Wouldn't that be great?
very soon.
Atmospheric entry on my mark. 3, 2, 1, mark.
Here we go.
So in a few seconds, the vehicle will start sensing the atmosphere. I said 22 kilometers from the center of Mars. And it's going to start to slow down very, very slowly at first, but then faster and faster and faster till it reaches about 7 Gs. I made that mistake on the video. It's actually 7 Gs, not 12. And so but we'll still very, very quickly slow down. And from 15...
In approximately 1 minute, InSight is expected to reach its maximum heating rate.
Oh, yes.
Plasma blackout is possible during peak heating and could cause a temporary dropout of telemetry. This could last for as long as 2 minutes.
Yeah, the gas that comes off the heat shield as it's slowing down, it looks like a meteor if you're on Mars watching the streak go by. That brightness of gas does interfere with the radio reception. And so it's possible that Marco will lose that signal while it's going through this very hot entry.
But not to be alarmed.
Not to be alarmed. It's part of the design. We completely expect it.
Radio Science reports plasma blackout as expected.
Okay. Oh, wow.
Ground stations have reported plasma blackout, still receiving InSight telemetry via Marco.
Marco Alpha has carrier interruption.
InSight should now be experiencing the peak heating rate. Portions of the heat shield may reach nearly 3,000 degrees Fahrenheit as it protects the lander from the heating environment.
That's hot.
Marco Bravo shows carrier interruption, but still in lock.
InSight has passed through peak deceleration. Telemetry shows the spacecraft saw about 8 Gs.
Marco Alpha and Marco Bravo maintain lock.
Radio Science reports carrier detected.
Yeah.
So several different communications coming in.
InSight is now traveling at a velocity of 2,000 meters per second.
It seems to have passed this very critical point of peak heating and peak deceleration. the next big step is parachute inflation.
And you can see that on our timeline on the bottom of the screen. The next event is parachute deploy.
InSight is now traveling at 1,000 meters per second.
Very close.
Once InSight slows to about 400 meters per second, it will deploy its 12-meter diameter supersonic parachute. The parachute will deploy nominally at about Mach 1.7. Standing by for parachute deploy.
Radio science reports sudden change in Doppler.
Ground stations are observing signals consistent with parachute deploy.
Marco Alpha, Marco Bravo, maintain lock status.
Telemetry shows parachute deployment. Radar powered on. Heat shield separation commanded.
This is really good news so far.
That's fantastic.
I'm on pins and needles.
We have radar activation where the radar is beginning to search for the ground. Once the radar locks on the ground and InSight is about 1 kilometer above the surface, the lander will separate from the back shell and begin terminal descent using its 12 descent engines. Altitude convergence, the radar has locked on the ground.
Yes.
Standing by for lander separation.
Carrier interruption on Marco Alpha and Marco Bravo.
Lander separation commanded. Altitude 600 meters. Gravity turn, altitude 400 meters.
We're getting there.
300 meters. 200 meters, 80 meters, 60 meters, 50 meters, constant velocity, 37 meters, 30 meters, 20 meters, 17 meters, standing by for touchdown. Touchdown confirmed.
That's fantastic.
This never gets old.
No, it doesn't, Rob. Control
what a
room
relief.
just erupted.
Fabulous,
Hands
fabulous.
with the Marco team
Marcos.
there.
Christine, you did great. Jim Preiser, one of the key designers at Lockheed. Sandy Krasner, what a great
relief.
team. What a great This is really fabulous.
Fantastic news.
Thank you.
Lots of fist bumping going on in there. What a relief. We've cut over to the camera over in Times Square. Boy, people are weathering the rain to see this.
They can't help it. This is the hardest part. Getting to the surface of Mars is very hard. This thing has a lot more to do, though. There's a lot more to go on both today and the days that follow before the science can begin. But just getting a vehicle from Earth to the surface of Mars is no mean feat.
And Rob, could you talk about that? I mean, just the mere accomplishment here that we're seeing.
You have to understand that this vehicle is very complicated. It uses 12 engines. Each of those engines are pulsed 10 times a second, producing these little tiny impulses, almost like little bullets that keep the vehicle going at a constant velocity as it approaches the ground, and still going over 5 miles an hour. So those legs feel a fair amount of crush. We still don't know the state of the vehicle right now. We need to look to make sure there are no rocks nearby. The solar panels will be in just a few. In about 5 to 10 minutes, will begin to open up. They're waiting for the dust to settle, because the dust there's certainly a lot of dust being lifted in the air around the vehicle right now, which is now just settling.
So we're standing by after touchdown. It waits a couple of minutes to give us an X-band beep. And so we are standing by for that. It's a communication that comes directly to Earth from InSight.
Yes. And it goes to the Deep Space Network. There's also something that might be happening now, if we're very lucky. InSight might be able to relay an image or a partial image taken just a couple minutes after landing. So I'm standing by hoping to see that. But if that doesn't happen, we'll certainly get more images later in our Odyssey pass in about 5 hours.
We see Bruce Banner waiting for it.
They're
I don't know if they see it yet.
They're waiting. That's Justin Mackey and Bruce Banner looking carefully at the cameras to see what they might see. They're waiting for the image to come back.
So this is the first image from InSight itself. InSight
Correct.
is taking a picture with one of its 2 cameras.
Yes.
It's probably a view of what's directly in front of the spacecraft, right in front of the lander. This is a camera that it would be using to figure out, is this a good space?
Exactly.
Is it a good place to put down our instruments? So it is going to take an image and then send that image to the Marcos. The Marcos, in turn, will relay it back down to Earth.
That's correct. They got it. Oh, now. Let's just wait. Let's see what they saw. There it is. Wow, right. Look at the great place. That's a good scene. That's not far from where we'll be able to deploy the instruments. So it's great. I don't see a lot of.
Let's explain that image. Now, this image has a dust cover on top of it.
EDL.com, we have lost the signal for Marco.
You can see potentially a lot of.
Radio science reports
debris that might be on the camera.
LOS for UHF.
So we don't know what I'm looking
Thank
at.
you, everybody on EDL.com.
All right.
Yeah. Yay, Marco. Congratulations.
Meantime,
Oh, there it is. You can see a better view. You can see that really is debris. And there's the horizon back there, the bluish sky. That's part of the lander deck on the front left. I can't make out, but it looks like there's not a lot of rocks in the field of view. But those dots you see there are very likely to be dust particles on the lens, the dust cover, which will be removed.
and we'll get another shot later on.
Yes. And a better, clearer view after the dust cutter is removed. So InSight's, CubeSat's relay communications job is done. they're now flying on. They're now taking pictures back toward Mars. Hopefully, MRO, which flew overhead, might have been lucky enough to capture the descent of this InSight lander under its parachute while this was going on. MRO was flying overhead, recording the data, also monitoring the transactions and recording every bit of signal it could. But it also had the ability to take a picture, and maybe like we did with both Phoenix and later for Curiosity rover, we might be able to see the parachute inflated as well.
That would be fantastic. We are standing by now for that X-band beep.
Yes.
InSight phoning home saying, I'm here and I'm okay.
Well, thank you for
System based on InSight Cord, the DSN and X-band.
Radio science reports X-band carrier detected.
DSN and X-band radio science have acquired the X-band touchdown signal for InSight. X-band will continue for 4.5 minutes with InSight in nominal mode.
Copy that. Thank you.
Flawless.
Perfect.
Flawless.
We've got the beep. This was perfect case scenario.
This
in my book.
is what we really hoped and imagined in our mind's eye. Though we spend most of our visualizing all these bad things can happen.
That's true,
sometimes things work out in your favor, and we'll look very carefully at the data to see what might have, how well it went. But it certainly looked like it was a very successful and perfect landing. We'll have to see as we get more data how well things go. And as the vehicle proceeds, the solar panels will be deployed. Hopefully, we're not on a tilt. It doesn't look like we are, but from the image. But the solar panels will be deployed safely, we hope. And we'll get confirmation of that around 5 o'clock local time here in about 4.5 hours, 5 hours from now.
And this is such a difficult feat in that because of the one-way light time, there is no way that any of these engineers could possibly control the vehicle. It all has to be done in commands and software.
We have to train it to do this work on its own.
Radio science reports nominal carrier 30 seconds past the first acquisition. So we're all nominal on the surface.
So the vehicle is completely nominal, reported nominal. It's happy. The lander is not complaining. We had a way to tell us if it was unhappy, and it wasn't. It's not unhappy. It's in a normal mode, and so it's going to chug along for the rest of the afternoon on Mars and finish the activities.
All right. Well, Rob, I know you're anxious to get in and
Yes.
congratulate the crew. Thank you so much for sitting here and helping us out. Explain EDL.
Thank you.
All right. Well, I'll let you go and go congratulate your friends.
Thank you.
All right. Take care.
EDL Palm MRO Electra on InSight Ops. Opto loop recording completed at 20:04:34.
as we had promised, we said we'd bring back the administrator to get your take on what was it like to be in that control room. Jim, what was it like?
Well, I'll tell you, it was intense, and you could feel the emotion. It was very, very quiet when it was time to be quiet, and of course very celebratory with every little new piece of information that was received. It's very different being here than watching it on TV, by far, I can tell you that for sure, now that I've experienced both. And then, of course, you know, what's amazing is as soon as it was over, I got a call on my cell phone, and it was the phone number was all zeros. And whenever I get a phone call that's all zeros, it's got to be somebody important. I answered it, and it was the Vice President.
Oh, my gosh.
He watched the whole thing. He is absolutely ecstatic about our program. As you're aware, he's the chairman of the National Space Council, and he's been, of course, a keen advocate for what we do. To have him call within seconds of mission success is tremendous. And just so everybody knows, he wants me to say congratulations to everybody here at NASA and all of our international partners and everybody who has contributed to this mission. What an amazing day for NASA.
It is an amazing accomplishment in that this is something that is happening millions and millions and millions of miles away, and these people are able to do it.
Incredible. And what's fascinating is the whole time I'm watching it, I'm thinking every milestone is something that happened 8 minutes ago, because that's
Yes.
the time lag to get a signal from Mars to Earth.
Yes.
And so it's kind of you know, it's exciting, but then you have to step back and realize that this has already occurred in history. So it's a unique experience, incredible, and just the enthusiasm here is incredible.
So what's for the future? Looking ahead, 2020?
Well, let's get through December. So for the rest of we think about what's happening next. December 3rd, we're launching another American astronaut to the International Space Station. So that's going to be a big achievement, and it's going to be on a Russian Soyuz rocket that the last time we launched a human was not successful.
That was scary.
It was scary. But we figured out what the problem is. We're moving forward, and now we've got that underway December 3rd. Going forward from there, we're going to get the first science data back from the Parker Solar Probe on December 7th. So that's not too far away either. And then we've got OSIRIS-REx that will be in orbit around Bennu shortly after Christmas. So no shortage of exciting things. And then on January 1st, we're going to fly the New Horizons mission, which, for people who are not aware, that's the mission that went to Pluto back in 2014, gave us stunning images and data and information science on Pluto. And now that mission is still going strong. It's in what we call the Kuiper Belt now, which is an asteroid belt well beyond Pluto, and it's going to be taking images of Ultima Thule, which is an object in the Kuiper Belt, which we have never been able to go out there and take images of anything at close range before, and now we're doing it. So you ask what's happening next?
I'm sorry I asked.
we have. Right now at NASA, there is more underway, probably than I don't know how many years past. But it's like, you know, there's a drought, and then all of a sudden there's all these activities all at once. So we're busy. We're going to be working through the holiday, but a lot of amazing discoveries to be made, and we're looking forward to it.
It's so funny because our Ask NASA question you basically answered is, does the success of NASA InSight influence the timeline for future manned lunar or Mars missions?
Well, certainly everything we learn about Mars at this point is going to help us understand how to do in-situ resource utilization. So InSight could actually provide some really good information about whether or not there's liquid water on Mars, and maybe even where it is and how to get to it. We strongly believe that there's liquid water, 10 kilometers under the surface of Mars. So the key is, the answer is yes. The more we learn, the more we're able to achieve. And so to get to Mars, yes. But the lunar missions, the President's first space policy directive is to go to the moon, to go sustainably with international and commercial partners. So when we say sustainably, that means we're going to have reusability built into the system. And we're going to test and prove technologies at the moon that ultimately we can replicate at Mars. So we're going to retire risk, prove human physiology at the moon, which is only a 3-day journey. which means if something goes wrong, you can get home safely. We saw that with Apollo 13. But we need to use the moon as a proving ground to accelerate our path to Mars. In the meantime, we're doing missions like InSight to learn as much about Mars as possible. InSight is going to help us understand really asteroid impacts as well, because it's got a seismometer, which is going to help us know how often is Mars getting impacted with asteroids. And if we're going to send humans there, it'd be important to know if those humans are going to experience asteroid impacts.
And that's pretty much our goal, is always learn from our missions and build upon those missions.
One after another. And NASA has a long history of doing just amazing work in building on its past successes and, in fact, its past failures.
That's true.
I'll tell you, what an amazing time to be at the helm of this extraordinary agency.
Well, we are so glad that you are here to share it with us.
Well, again,
thanks for joining us.
A true pleasure. Thank you.
All right, and I'm sure you need to go in there and celebrate with those folks, but thank you for stepping out for us.
Absolutely. Thank you so much.
Take care. Now, Mars exploration is cool stuff, but if you're not convinced just yet, just talk to the InSight scientists and engineers. No one conveys the excitement more than the people who actually work on the mission. So earlier this year, the outreach team filled up a van and went to 15 California cities. They called it the InSight Roadshow.
So we're here in San Francisco at the Exploratorium, and this is part of InSight's Roadshow. Since it's the first interplanetary mission we've ever launched from California, we're actually doing a lot of public engagement activities along California.
And we're just talking to the public and talking to them about InSight and getting them excited and sort of sharing information that they probably wouldn't get just from a website.
We have Mars globes and Touchables kits. We have replica of the actual launch vehicle that's going to be taking InSight to Mars. We have a selfie station with fun props. People can take pictures. Children really, really like Mars.
We have a jump station where we invite kids to come in and jump. We have a little seismometer on the floor which measures ground motion. So if students can come and jump next to it, they can actually see their recording on the screen and they make their own quake.
I've had people come to me and say, this is the most I've ever understood about a space mission. I'm so happy I came because now I understand what you're doing, I understand why it's important, and I'm really excited.
You kind of imagine how it looks, but seeing it in person actually puts it in perspective. She was able to explain a lot of what happens, the cameras, what goes into the ground. It's a great exhibit, both for myself and also for kids that want to learn about Mars.
Okay, we want you to meet another Mars veteran here at JPL, our director, Mike Watkins. You were a mission manager for Curiosity.
Absolutely. I think this is the 5th Mars mission I've worked on,
Really?
5th Mars lander. So maybe we're getting the hang of it finally.
Does it ever get better? I mean, does it get old? It's always the same?
No, it doesn't. I mean, I think we're just as nervous every time. The whole landing sequence, and it's just such a crazy time, and we can't do anything. It's this feeling of helplessness, right? Because the spacecraft's on its own, and everything we could do, we did a day ago. And so I think you just always have that nervousness. But, we have confidence in the team. We have confidence in the engineers and scientists that they did everything that they could do. And you have to put it in their hands.
And it's our 8th successful landing, so we learn from this, we learn a little more, we do it better the next time, pretty much.
Absolutely, and we have had one failure. We learned from the failures too. So in fact, we learned from all the failures from all the missions, even if they're not JPL missions or NASA missions. Each one of them tells you a little something, an extra test you should do, an extra thing you should guard against, in the Mars atmosphere or on touchdown. And so we've learned from all of these, and luckily we've recently been very successful.
And we're always trying something new. We're always trying to learn something new. We had a situation this time. Odyssey couldn't be in place to give us bent pipe communications. And so Marco came about.
The Marco is just an incredible success story. Exactly as you said, we couldn't have Mars Odyssey do the real-time bent pipe for the EDL events. We would have had to wait a couple of hours and have the replay from Mars Reconnaissance Orbiter. So we embarked on this kind of crazy idea to build these 2 little CubeSats. And CubeSats are something that high school kids can build these days, but they go up and they go around the Earth. They go around the Earth.
Right.
These are the first interplanetary CubeSats. First time we've ever sent CubeSats outside the Earth's orbit. And their sole purpose was to do the relay. So they have this very cool X-band planar flat antenna there, and they relayed the UHF signals in real time for us, and it was just amazing. It's built by a lot of early career folks here at JPL with a little bit of adult supervision, but no, the engineers, they just did a fantastic job on Marco. It exceeded all of our wildest expectations. They worked perfectly. We built two because we thought maybe one will get there. They both got there. They both worked. It's just a great tribute to the Marco team. You saw them in there. They had their special black shirts.
Yes.
Just a fantastic thing. And not only did it work for this mission, but I think it opens up the door for more small missions like that. We could actually put cameras on them and put other instruments on them. They're much less expensive. So there's, I think, a whole new door. We just opened a door to a new class of planetary science thanks to the Marcos. And so
for the CubeSats, they were just made with off-the-shelf parts.
Some combination of off-the-shelf parts and some new stuff that we did. We had to build a special radio, of course, because it has to talk to the Deep Space Network. The antennas are a little bit new technology, but a lot of the stuff is pretty standard stuff that you could replicate at much lower cost.
So what do you think in terms of the future, that other missions will be carrying their own relays and not having to depend on a bent pipe from a orbiter?
They might carry relays. They might actually carry scientific instrumentation. They can do more than just do relay. They can actually take pictures. They could do spectrometry. They could do lots of other stuff that we'd like to do with orbiters. And so there's a chance we could send them to Venus. We could send them to asteroids. We could send them to Mars. I mean, there's lots of stuff we can do, and I think we're just learning the capability of what we can miniaturize and what we can put on these CubeSats. But this is a great, a great first effort.
Absolutely. Well, we have one question for you. It's a social media question from George K., age 9, from the UK. How long did it take to plan and build this mission, InSight?
Well, that's a great question. So I have two answers to that.
Okay.
InSight itself, typically our missions take from the time we start the mission to the time we launch it. It's about 4 to 5 years. In the case of InSight, two things happened, one to our advantage and one not to our advantage. The first is we had a lot of heritage from a mission called Phoenix. So a lot of the design work had already been done because it was done for this mission Phoenix, and even before that for Mars Polar Lander. So a lot of the basic design we kind of inherited for this mission. On the other hand, we had a little bit of bad luck in that the instruments, the seismometer is so unbelievably precise. It's so incredibly accurate and hard to build that we couldn't quite get it ready. So we're doing that in partnership with the French and a lot of other countries in Europe, including the UK and Switzerland and other folks. We couldn't quite get that ready to go for launch. So we had to actually wait 2 years, and took an extra 2 years then because of that. So Mars and the Earth are only lined up to launch about every 26 months, so we had to wait another 26 months. So that took us a little bit longer.
Well, speaking of the internationals, that's a perfect segue for where we're going next. Throughout this program, we've been trying to introduce you to the people behind the scenes, and for the InSight mission, it requires that we go beyond our borders. This is truly an international mission. Let me introduce you to Domenico Giardini, a Swiss-Italian scientist who studies earthquakes and Marsquakes.
Some of us have been in this mission for 20 years. It's a lifetime project. I'm Domenico Giardini. I'm an Italian living in Switzerland. I work on earthquakes, and therefore I will work on Marsquakes. I'm a professor at university. Seismic risk, seismic hazard are my main field of applications. InSight is a mission which is geared to measure the physical parameters that help us to characterize the interior of Mars. There are two main reasons why it's important to do by international cooperation. There is a big motivation coming from all the different parts to complete it, and the community grows much faster and the knowledge grows much faster. The Swiss role in this mission to deliver the electronics for the seismometer, and we will provide daily routine analysis and check if there are seismic events or meteoritic impact in the planet itself. This is what our students will work on, how the planet developed and what is the future, and that has a direct relevance on how we understand about the Earth. It's so interesting.
And that partnership goes far beyond individual scientists. Take a look at this. It is a picture of the calibration tool on the deck of the InSight lander. It's what the team uses to calibrate the cameras on Mars. And notice the flags and logos. It's recognition of our international partnerships with the French government space agency, CNES, and also the German Aerospace Center, DLR. And it is my pleasure to welcome SAIS Project Manager Philippe Ledet from CNES and Executive Board Member Hans-Jörg Dietz from DLR. So I can't imagine a better day.
Oh, yes.
What was your reaction?
So I am very enthusiastic and very grateful for all the people of the mission, and also my thoughts are going to the team, the CNES team, and to the science team, to Bruce Bannert and to Philippe Lognonnet. Now we have a marvelous picture of the ground, and now the work to deploy the seismometer is beginning. So a new adventure in the best conditions. Thank you for that.
Definitely a new adventure. Hans-Jörg, what's your feeling? The HP Cubed is on that deck. It will be ready to go.
Yeah, it's now a job now. But first of all, I'd like to congratulate our partners here in the US. And this was a great day and a great job they did. It's not easy to land on Mars. That's what we know. And it's a dream for me as well. Because the first time that we land on Mars with an instrument, at least as I has experienced it, and so it's a great day, and it was really exciting so far. Now the job starts for us.
Well, it's funny, Philippe, you had once said you're a musician as well. He plays jazz. You see exploration and music very similar.
Yeah,
How's
yes,
that?
very similar. Because the human management of all that activity is exactly the same. The technique, it's different. You have a seismometer and you have an orchestra. But the whole thing to find the best talents and things like that are exactly the same. And to deliver on time, to be ready, and to have the best performances. Everything is similar.
And we should let people know that we won't be able to be collecting science right away. Is that correct?
Yeah.
We will be collecting science, several months from now?
We are beginning, the deployment is going to take about 2 or 3 months. Of course, we will have some data during the deployment, but the best data to make the best science will be about the beginning of March.
All right. So
we prepare now, and
we prepare now.
Yeah, now it's the time. Yeah, but it was a great job so far. Also for our team and our teams, all the teams, and as you said, it needs a lot of people to bring it up to Mars and make it a successful mission.
Well, I have to say congratulations.
Yeah. Congratulations.
All right.
Thank you.
Thanks for joining us.
Yeah, thank you.
Well, here's another profile now. Meet Ravi Prakash. It's his job to keep InSight healthy on Mars.
We get to explore the universe and see things that no one has ever seen before. My name is Ravi Prakash, and my job is to keep InSight healthy when it's on Mars. InSight is the first spacecraft that's going to go to Mars and try to understand how rocky planets have formed. Spacecraft team, how's power looking? A healthy InSight spacecraft is healthy batteries. We have heaters all over our spacecraft that keep our spacecraft warm enough so that it operates the way it should.
Power is nominal. Spacecraft battery is fully charged.
We look at these things as well as many other parts of our spacecraft on a daily basis to make sure we have a successful mission. There are thousands of people working on InSight, so the systems engineer is responsible for understanding how changing one part of the spacecraft ripples through the entire system and how that affects all the other parts of the spacecraft. I actually worked at JPL for 8 years and then left for about 3 years to work for a nonprofit where I used my engineering and design skills that I learned at NASA to help people in poverty. I realized that the stuff we do here impacts billions of people around the world. Every single person, whether they realize it or not, has been impacted by NASA technology. We are the next generation of explorers.
All right, let's meet Ravi Prakash in person. Ravi is in our sandbox. That's the JPL In Situ Instrument Laboratory. And wait a minute, Ravi, where did that beard come from?
Hi, Gabe. Yeah, there were about 10 of us that decided on the day we launched to Mars that we were going to shave and then not shave again for 7 months until we landed on Mars. So I am extra excited that we landed, not only because we have a mission on the surface of Mars, but I have 2 little girls at home that love to pull my beard, and so I can finally put an end to that.
All right, so Ravi, help us out. What happens next? Now, clearly, InSight is not out of the woods just yet, correct?
You're right. So we have some very important steps ahead of us. The first is that we have to deploy our solar arrays. This is what the spacecraft is doing right now. It's deploying these 2 solar arrays so that we get energy from the sun. This is one of the most important things that we have to do right now. After that, we're going to do a series of checkouts on our spacecraft to make sure that everything survived this harrowing entry, descent, and landing onto Mars. And then once that's complete, after the next few days, we'll start deploying our instruments onto the surface of Mars.
So what exactly is involved with the instrument deployment?
So this is the first time we're using a robotic arm to put instruments on the surface of Mars. This is a process that will put our seismometer on Mars as well as the heat flow probe. And it ends up taking about 3 months, which sounds like a really long time. But this is because, We have to be very careful and make sure everything happens just the way it needs to. Unlike Earth, we can't send a technician if something goes wrong, and so we just want to get it right the first time.
All right, and we, in our interview, just heard that we may be looking at not until March before we get science?
That's right. We get some amount of science immediately as far as the environment of Mars. We get wind data, temperature data, magnetometer data. But then once we start getting seismic data, that will be in the March timeframe.
All right. And can you explain to me, Ravi, the ISIL, the test bed that you're at? What do you do there?
So this is a Martian sandbox. For the past few years, we've had a great team that's been testing, deploying our instruments on a variety of different slopes and rocks. Now that we actually are on Mars, we're going to transform this area to look exactly like the place we landed and test out deploying our instruments one more time before we do it on the real thing.
All right. Thanks, Ravi. Congratulations.
Thanks so much.
Now that InSight is on Mars, it needs some changes. InSight is no longer cruising to Mars, so the team no longer needs the cruise mission support area. In a little while, the team will hand over operations to a new group sitting in another JPL control room. This is the Surface Mission Support Area. It's in another building here at JPL. This is where the team will be operating InSight from here on. So the handover is the final step, and that will take place at about 1 o'clock our time. That's about a half hour away. For us, it's time to say goodbye. Our congratulations to the InSight team, and special thanks to our EDL system engineers, Christine Soleil and Julie Wards-Chen. Stand by for a news briefing on NASA TV at 2 p.m. Pacific, 5 p.m. Eastern. And for those of you who want the latest information on InSight and Mars, go to mars.nasa.gov/insight and nasa.gov/Mars. And thank you all who shared pictures on social media. It was wonderful to share this historic event with you. We have some pictures for you that we'll leave you with. Enjoy, and congratulations, InSight.